Solving triangles. So some problems will ask us to solve a triangle. This means find all of the missing angles and sides. We're going to need some type of scientific calculator, and you can use the Desmos scientific calculator if you'd like at that website, desmos.com/scientific. Now, when using a calculator, you want to make sure to enter the entire expression to avoid round-off error, and report values to the nearest hundredth unless asked otherwise. There's going to be a few tools that we're going to need when solving a right triangle. So in this case, we're still thinking about right triangles. So we're going to use some of our trigonometry. We always have the Pythagorean theorem if we need it. And we have the fact that the three interior angles in a triangle add to 180 degrees. So these are kind of the three things that we have at our disposal when we're solving a right triangle. So the way that I like to kind of approach these is put the given information both in the triangle and in some kind of table where you're keeping track of all the values. So here we're given that B is 4 units and that angle B is 10 degrees. And notice that here our angle is labeled outside, kind of on the corner of the vertex as opposed to the inside, and we can do that because it can't be confused with any other angles. All right, down in kind of the bottom corner, I'm going to kind of keep track of the three sides and the three angles. So I have a little a, little b, and little c, and that's pretty common to keep to represent the lengths of sides. And then I have big A, big B, and big C for my angles. Now some of these I'm already going to know. So like angle C is 90 degrees. I know that. I'm in a right triangle. All right. And angle B is already given. It's 10 degrees. Let's look. Side B is given as 4 units. Okay, great. But that means I'm left with finding little a, little c, and then big A for the angle. So some of these, like I notice that I can find the measure of the angle A just by using the fact that all the inside or interior angles of a right triangle have to add up to 180 degrees. So I'm going to go like A plus the measure of B plus the measure of C have to be 180 degrees. B and C together is 100. So A plus 100 degrees is 180 degrees. So A would have to just be 80 degrees. So I put that in my table. And notice I rate it in both places. Okay, so now I have two sides to determine. So let's do that. All right, doesn't really matter which one we start with. If for some reason you can't find one, you can always switch to the other. So let's start with finding the length of side little a. All right, so I'm trying to find A. Sometimes I'll write it like that, kind of what I'm trying to do. Now, I want to relate some of the given information. It's okay to use information that you found kind of along your journey, but if that's incorrect, it can lead you to more incorrect answers. So if I can, I'd like to depend on things that are given to me at least to start with. So I see that I am given the length of side B here, the angle 10 degrees, and I'm after this length A here. All right, so I'm after this one here. So I want to relate A, B, and this angle. Okay, well, I have my right triangle trigonometry, right? So I'm ready to go. So if I am a little bug standing at 10 degrees, or a little person, or whatever, then B is, and again, just in reference to this angle, B would be the opposite. A would be the adjacent side. Okay, opposite and adjacent. Well, I gotta write out my SOHCAHTOA, so I don't forget, SOHCAHTOA. And I see that tangent is the function that relates opposite and adjacent side. So I can write tangent of 10 degrees is opposite over adjacent, so 4 over A. And now I can solve this equation for A. I can do that because it's the only unknown, right? It's the only variable. So solving for A, I get A is 4 over the quantity tan of 10 degrees. So I need a calculator for this so that I can get some type of approximate answer. So I'm going to pull in my Desmos scientific calculator. All right, so when I do that, I get 4 divided by the tangent of 10 degrees. So notice that our three main trig functions, sine, cosine, and tan, are all here. and I get 22.69 degrees. Now, scientific calculators have two modes. They have degree mode and radian mode. And we want this to be in degrees just because we're kind of already given things in degree mode. So I make sure that I'm in degree mode, but I can toggle it up here. So I want degree mode. Okay, so I have 22.69. Oh, but this isn't degrees, is it? Because this is a side length. All right, so this is 22.69. 22.69. And I don't have any units, so I can just leave it like that. I still need degree mode though, because I'm putting in 10 here. So let's go back to the calculator. When I plug in 10, since I'm in degree mode, I don't need a degree symbol there because it'll read it as 10 degrees because I'm in degree mode. All right, now let's find the length of C. Now, there are two ways that I could find the length of C. I could find the length of C just by using the Pythagorean theorem, but I noticed that one of my lengths is approximated. So let's use right triangle trigonometry to find that length instead. So what I'm going to do is now try to relate. Let's see. I'm going to go find the things I'm trying to relate here. I want to relate this given angle, 10 degrees, this given side 4, and then the thing I want, which is C. So now I'm trying to relate, let's see, the opposite side and the hypotenuse. Opposite and hypotenuse, that's sine. Okay, great. So sine of 10 degrees is opposite 4 over hypotenuse C. Now notice that C is the only variable that I have, and I can just solve for C now. So rearranging this equation, I get C equals 4 over sine of 10 degrees. All right, so when I go in here, I get 4 over sine of 10 degrees. And I get 23.04, but okay, we got to remember that this is not in degrees, and I know that just because I am finding a side length, so it's not an angle, so that's how I know that. And so I have that in both places, great. And then I found my A value, and I put that in my little table, and so I have my work organized, and I have all of my values reported. So I'm done, I've solved the triangle.